Apple has made a lot of incredible products over the years. The iPhone changed how we communicate. The MacBook changed how we work. The AirPods changed how we listen to music. But nothing, and I mean absolutely nothing, that Apple has ever built comes close to the engineering challenge of the Apple Vision Pro. This is not just another gadget. This is the single most complex consumer device ever manufactured at scale in human history. And today, we are going inside the factory where it is made, breaking down every single step, every material, every machine, and every test that turns raw components into the most advanced piece of technology you can currently buy with your own money. Before we even get to the factory floor, we need to talk about what Apple Vision Pro actually is, because most people who have not used one have no idea what they are really dealing with. This is a spatial computing headset. It has 12 cameras, 5 sensors, 6 microphones, 2 displays, and a custom silicon chip architecture that does not exist in any other product on Earth. It weighs just under 600 grams. It runs for 2 hours on a single battery. And when you put it on, the digital world it creates around you is so detailed, so sharp, and so perfectly overlaid onto the real world around you that your brain genuinely cannot tell the difference between what is real and what is not. Building something like that to a standard where it works perfectly every single time for every single customer at a price point Apple can actually manufacture and ship at scale is an engineering problem so difficult that it took Apple 7 years and over $1 billion in research and development just to get to launch day. So let us start where everything starts, the materials. And the first thing you need to understand about Apple Vision Pro is that almost nothing in it is standard. Apple did not go to a supplier catalog and pick parts. They looked at what the product needed to do and then built materials and components from scratch that did not previously exist. The outer shell of the Vision Pro is a single piece of 3-dimensionally formed laminated glass, not flat glass that has been bent, not glass with a separate frame around it. One continuous curved piece of optical grade glass that wraps around the front of the device. To form glass into a precise 3-dimensional curve at the quality level Apple requires, the glass has to be heated to an exact temperature, pressed into a custom mold under precise pressure for a precise amount of time, and then cooled at a controlled rate. If any of those variables is even slightly off, the glass distorts, and distorted glass in a device where your eyes are 2 centimeters away from 2 micro OLED displays would make the entire product unusable. Apple's glass manufacturing process for Vision Pro is something the glass industry had genuinely never done before at this level of precision and at this scale. The aluminium frame that sits behind the glass and gives the device its structure is machined from a single billet of aerospace-grade aluminium using a CNC milling process that takes hours per unit. The machine removes material from the billet with cutting tools that operate at tolerances measured in microns. 1 micron is 1,000th of a millimeter, and the frame has to hold every single optical component in the device in exact alignment, because if any camera, sensor, or display shifts by even a fraction of a millimeter from where it is supposed to be, the spatial mapping of the device breaks down and the user experience falls apart. So the frame is not just a structural component, it is a precision optical instrument, and it is machined to standards that would be considered extreme, even in aerospace manufacturing. Now let us talk about the displays. Because the displays inside Apple Vision Pro are unlike anything that has ever been put into a consumer product before, each eye gets its own micro OLED display, and the resolution of each of those displays is 4,000 pixels per inch. 4,000. For comparison, the screen you are probably watching this on right now, whether that is a phone, a laptop, or a television, is somewhere between 100 and 500 pixels per inch. The Vision Pro displays are between 8 and 40 times more pixel dense than the screen you are looking at right now. And the reason Apple needed that level of density is simple. In a headset, the lenses are magnifying the display and projecting it directly into your eyes from a very short distance. At lower pixel densities, you would see the individual pixels, the screen door effect that ruined early VR headsets. At 4,000 pixels per inch, even with magnification, your eye cannot resolve individual pixels. All you see is a perfect, continuous, flawless image. Manufacturing micro OLED displays at this density and at this size is something that only a handful of facilities in the world can do. The displays are grown at the atomic level in clean room environments so controlled that a single dust particle in the wrong place during manufacturing would destroy the display entirely. The air in these clean rooms is filtered thousands of times per hour. Workers wear full bodysuits, gloves, and face coverings, and even with all of those precautions, the yield rate on micro OLED displays at this specification, meaning the percentage of displays that come out of manufacturing meeting, the required standard, is significantly lower than for conventional screens, which is one of the main reasons Apple Vision Pro costs as much as it does. Each display then has to be paired with a custom lens system. The lenses in Vision Pro are not simple curved pieces of glass. They are a stack of multiple optical elements, each one precisely shaped and aligned to work together to project the display image correctly onto the curved surface of your retina. The lens stack has to compensate for the way different wavelengths of light bend differently through glass, a phenomenon called chromatic aberration, because if it does not, you get color fringing around high contrast edges in the image. Getting this right requires optical engineering at a level usually reserved for scientific instruments and military optics. And Apple does it at scale, in a factory, for a consumer product. Now we get to what is arguably the most impressive part of the entire Vision Pro manufacturing process, the camera and sensor calibration. Because Vision Pro has 12 cameras and 5 sensors that all have to work together perfectly to create the spatial awareness the device needs to function. These cameras do not just record video, they track your hands in real time, map the geometry of the room around you, track your eye movements to know exactly where you are looking, and feed data to the R1 chip, which processes all of that information and sends it to the displays in 12 milliseconds. 12 milliseconds is faster than the blink of a human eye. It is faster than the human brain can consciously register a delay. Apple specifically engineered the R1 chip and the camera system to hit that 12 millisecond threshold because any slower and users would start to feel motion sickness as their visual reality and their physical reality fell out of sync. Calibrating 12 cameras and 5 sensors so that they all agree perfectly on where objects are in 3-dimensional space is a process that takes place on a dedicated calibration rig in the factory. Every single Vision Pro unit sits on this rig and goes through a calibration sequence that maps the precise position and orientation of every camera relative to every other camera, compensating for the tiny natural manufacturing variations between individual units. This calibration data is then written permanently to that specific device's memory. It is not a generic calibration applied to all units of the same model. It is a unique spatial map that belongs to that one individual headset. This is why, when you put on an Apple Vision Pro, it knows with extraordinary precision exactly where everything in the room around you is within seconds of starting up. The eye tracking system gets its own separate calibration pass. 4 cameras inside the device track the position of your pupils and the orientation of your eyes with enough accuracy to know exactly which pixel on the display you are looking at any given moment. This is not just a feature, it is fundamental to how the device works. The Vision Pro uses a technique called foveated rendering, where the display renders the area you are directly looking at in full maximum resolution and reduces the detail level in your peripheral vision where your eye cannot perceive it anyway. This saves enormous amounts of processing power and allows the M2 chip inside the device to deliver the visual quality it does without the battery dying in 20 minutes. But it only works if the eye tracking calibration is perfect. If the system thinks you are looking 2 degrees to the left of where you are actually looking, the high resolution zone moves to the wrong place and the whole illusion breaks down. After all the optical and sensor calibration is complete, every Apple Vision Pro goes through environmental and durability testing. The device has to function correctly across a wide range of temperatures because Apple sells this product all over the world. It goes through humidity testing. It goes through drop testing onto hard surfaces from multiple angles because despite being a precision optical instrument, it is also a consumer product that real people are going to handle in real environments. The audio system, which uses personalized spatial audio to make sounds feel like they are coming from specific locations in the 3-dimensional space around you, is tested and calibrated in an acoustic chamber. Every speaker driver and every microphone is verified to be performing within specification. And the full spatial audio rendering system is tested end to end to make sure that when you hear a sound coming from your left, it genuinely sounds like it is coming from your left and not from slightly above your left or slightly in front of. The light seal, which is the soft cushioning layer that fits around your face and blocks light from entering around the edges of the device, is made from a 3-dimensionally knitted textile using a process similar to what Apple uses for the Sport Loop Apple Watch bands. It has to conform to the contours of a huge variety of face shapes and sizes while maintaining a consistent light seal and remaining comfortable over extended wear periods. Apple makes the light seal in multiple sizes and fits, and the testing process includes fit testing on a diverse range of physical face models to verify that each size achieves the required seal and comfort characteristics. The eyesight display on the outer front of the device, the outward-facing display that shows an image of the wearer's eyes to people looking at them from outside, is a lenticular display. This is a display technology that uses a layer of micro lenses over the screen to create a 3-dimensional effect, making the displayed eyes appear to have depth rather than looking flat. Manufacturing a lenticular display at this size and resolution and integrating it into the curved glass front panel of the device is an engineering achievement that did not exist test in consumer electronics before Apple Vision Pro. When every test is passed and every calibration is confirmed, the device is assembled into its final form. The light seal is fitted, the headband is attached, the external battery is paired and tested, and the complete unit goes through a final end-to-end function verification. Every camera, every sensor, every display, every speaker, every microphone, the eye tracking, the hand tracking, the spatial mapping, the R1 processing latency, everything is checked against the specification one final time before the device is approved for packaging. Only then does it get gently placed into its box, sealed, and sent out into the world. Apple shipped Apple Vision Pro at a price of $3,499. And when you understand everything that goes into making one, when you understand the micro OLED displays grown atom by atom in a clean room, the aerospace-grade aluminium frame machine to micron level tolerances, the 12 individually calibrated cameras, the eye tracking system accurate to a fraction of a degree, the R1 chip delivering 12 millisecond latency, the lenticular eyesight display, and the testing process that every single unit survives before it is allowed to leave the factory, the price starts to make a different kind of sense. This is not an expensive product because Apple wants more profit. This is an expensive product because nothing like it has ever been built before, and building it right costs exactly what it costs. The first generation of any transformational technology is always the hardest, the most expensive, and the most limited version of what it will eventually become. The original iPhone was slow, had no app store, and could not record video. Look at what it became. Apple Vision Pro right now is the beginning of something. The display technology will get cheaper as manufacturing scales. The processors will get more efficient. The weight will come down. The battery life will go up. And one day, probably sooner than most people expect, the technology inside this factory will produce a device that fits in a pair of glasses frames and costs what a smartphone costs today. The factory in Shenzhen building Apple Vision Pro right now is not just making a headset, it is building the foundation of the next 20 years of personal computing. And every single unit that comes off that line, tested to destruction and calibrated to perfection, is one more step toward a future that Apple has been planning for longer than most people realize.